All right, let's get started. So my name is Jose Barreto, and I am a program manager with the file server and clustering team. And I also have with me here Brian and Hector, who are going to be doing a few demos along with me to show you some of these new capabilities in Windows Server 2012 in regards to storage and availability. I apologize, my voice is a little rough, but I was much worse this morning, I can guarantee you. So let's keep going. So one thing I want to make clear here is that we are talking about what is changing between Windows Server 2012 and Windows Server 2012 R2. So the focus of this talk is not to give you an overview of what happened in 2012, but actually to show you what is new and different in R2. So I want to say that up front to set the right expectations. We are going to talk a little bit about what we just did in 2012, and then we're going to talk a little bit about R2, and then go into details in three different areas. One is focused on VMM, management of storage. Then we're going to talk about file-based storage, and then we're going to close with storage spaces. So Hector is going to help us with the storage management part. I'm going to do the file-based, and Brian's going to close with storage spaces. All right. So how many of you have already deployed Windows Server 2012? That's a good number. Awesome. And the idea here is, if you've been deploying it, you probably saw that we had a whole lot of new capabilities, especially in the area of storage. So you obviously know about spaces, SMB3, the scale-out file server, VHDX support, and those are just a few highlights. Hyper-V Replica is huge, right? And on the System Center side, a lot of different things, for instance, storage pool classification, our support for SMAPI, file storage provisioning integrated into VMM, a lot of different block storage solutions that we support through SMIS, the iSCSI target provider that we brought in. So a whole lot of capabilities that we introduced really less than a year ago, right? But what we're talking about here is the fact that we are now solidifying our approach to storage through what you can refer to as software-defined storage, meaning there's more and more that is actually delivered through Windows Server in software. And the two main items in that road to a software-defined storage solution are, at a lower level, the use of storage spaces so that you can actually expose just a bunch of disks to Windows. So SAS disks exposed directly to Windows without controllers, RAID controllers, without a SAN, and Windows being able to deliver that reliable storage solution. And on top of that, the notion of having file-based storage as the way that you take that storage that's wired to one or two set of systems, typically two, so you get high availability, and expose that to a whole set of Hyper-V hosts. So the notion here is the connection between Hyper-V and your storage is done through regular networks, Ethernet networks, using the SMB protocol, which we, in 2012, elevated to the version 3.0, which has a lot of capabilities that we glanced at before. But the notion here is when you come to us and say, hey, Jose, I want to create a solution. I don't have anything. What do you think I should do? I would certainly start the conversation by explaining to you the capabilities in storage spaces and right next to it, starting to talk about the capabilities in our scale-out file server. Now, one of the things that are very important when you talk about these solutions is you have to have a management story to go along with that. And I hope many of you are using System Center, more specifically, many of you using VMM 2012 SP1, which we released not too long ago. And one of the things that we have that we delivered was the ability to manage a whole set of storage solutions, including the ability to manage the scale-out file server. Now, in this release, there are a few things in the R2 release of System Center that needed to be completed. So in 2012 SP1, there were some capabilities that were not present and that we knew we had to work on and deliver that to you. So a few things, for instance, enumeration through SMIS was taking a bit too long, so that got improved. For instance, the support for virtual fiber channel was delivered in the OS, but you didn't have that end-to-end support of the virtual fiber channel through VMM. And if you're deploying that, you need VMM to go and finish that solution. And that is delivered in 2012 R2. And also, very important when you're talking about rapid provisioning. So provisioning is really key part of deploying the VM. You have to get the bits to the host that you're going to use to run your virtual machines, or to the storage behind that host that you're going to use. And we had some technologies, for instance, ODX that was delivered in 2012, and also a solution for using difference in disks, which are also another way to get some rapid provisioning through the use of a base and a diff. So those important scenarios are being delivered through VMM now. Now, when you think about this, we already had a lot of other capabilities in VMM, as we talked about before, but those are some key scenarios that we need to close, which brings back the notion that in R2, we are really focused on delivering a complete story and getting you to have the whole solution being managed through VMM. So I want to start by calling Hector over, and he's going to show you some of these capabilities I just covered.
Alrighty, thank you, Jose. And good afternoon. My name is Hector Linares. I'm a program manager with the Virtual Machine Manager team. And some of the demos I'll have today really just touch on a few areas of where VMM has invested for the R2 release. I will focus on ODX and synthetic fiber channel support in this part of the demo. But if you want to see the full range of storage capabilities, my session is tomorrow at 3:15, session 344, and I'll go into deep dive for all of these capabilities. So the first one I want to show you is rapid provisioning. Now in VMM 2012 and SP1, we introduced SAN-based rapid provisioning, essentially using fiber channel iSCSI arrays to rapidly provision new virtual machines by cloning LUNs. And so we also introduced halfway support for diff disks, and which we've improved in R2. Now one piece that was missing in the story is how do you rapidly provision a VM to a CSV? In other words, a VM going into a volume with many other VHDs used by many other VMs. In other words, not the one LUN per VM scenario. And what we were missing was ODX integration. So in R2, now we've integrated offloaded data transfer, or ODX, into our new VM from template workflow. For those that are familiar with the VMM, we use templates to create new virtual machines. Template has hardware config, OS config, and a few other settings, and then you stamp out new VMs from a template. So in this particular demo, let me fire this off. So the first thing I'm going to show you is, let's deploy a VM using the traditional bits mechanism. And bits, for those that are not familiar, background intelligence transfer service, is essentially a way of transferring data from one location to another, essentially over HTTP or HTTPS. And it's very flexible. Gives a lot of great support for restart of a job, etc. Now, as you can see, one of the issues with ODX is that you've got to read the file from the source and write the file on the destination and transfer over the network. So you're consuming CPU, you're consuming network. And if you have this turned on with secure HTTPS, then obviously it's going to consume more CPU on the source, well, source and destination. So what I've done here is essentially kicked off a bits transfer. I only let it go for 30 seconds, and it only transferred about 7% of the file. So it's a 7 gig file, roughly 500 megs-ish, depending, right? And so then I took the same template, same source, library, same destination, your Hyper-V host, and now I'm using ODX on a NetApp array. So this is a NetApp FAS 2240, and with the latest firmware. And so now I've done the same deployment using offloaded data transfer. What you're seeing, the difference that you're seeing here is that there's no CPU load or network load on the source or destination, because essentially you're offloading everything to the underlying array. And in a few seconds, what you're going to see is that not only did I transfer the entire file in around the same time, but now I'm actually starting the VM, and it's now going through customization. So in the same amount of time that I transferred 500 megs using bits, now I can get a full VM deployed and ready to go into customization. So that's our ODX, that's our integration with offloaded data transfer. And just to be clear, we've done this only for new VM from template. Now there's other workflows like store VM to library, deploy from library, cloning VMs. We haven't optimized those workflows yet. But for R2, we've done this for rapid provisioning of new VMs. Okay, let me switch over to the second demo. And so another great feature that Hyper-V introduced is synthetic fiber channel or virtual fiber channel HBA support. What this essentially does is you can now unmask a fiber channel LUN directly into a VM. No need for pass-through, no need to expose it to the host. You basically get full isolation all the way up to the virtual machine. This is great, and so Hyper-V, Windows Server 2012 supports that. VMM SP1 actually could import VMs that were configured with virtual HBAs, but we had zero management. You couldn't put it into a template. We couldn't deploy them with a virtual HBA. We didn't do anything special. We didn't break anything. Well, we didn't help the management story. So in R2, what we've done several things. We've introduced support for host-level virtual SAN configuration. For those that are not familiar with the virtual SANs, when you have a fiber channel port, you can have one or many on a Hyper-V host. You essentially have to group them into a virtual SAN. Once they're in a virtual SAN, you think of it as a network vSwitch. Once they're in a virtual SAN, you connect a virtual HBA to that vSAN. So the first thing we do is now you can go into a host and actually configure that. So I'll show you that first piece. So I've got one host in particular here. I'm going to go into the properties. And if we go into hardware, on the left-hand side, I'll click on hardware, and then scroll down, and you'll see that we've got great information for network adapters, what switch they're connected to, et cetera. And if we continue scrolling down, we also have fiber channel information. So this is all the data that we pulled from the Hyper-V host. And then you can take those fiber channel HBA ports, fiber channel ports, and then group them into a virtual SAN. So very straightforward, needed as a first step before you start deploying VMs with virtual HBA. Second thing we did, now we get into the management piece the template piece. If you go into a VM template now, I'll go again to the hardware config of the virtual machine this time. We've also added now the ability to add up to 4 virtual HBAs per VM template. And then you can then, at this point, we don't have there's no fabric, it's not deployed to a host. So you can either say no classification or specify a fiber classification, and you can bind it later. Great. So we've got virtual SAN support. We've done it now for the template. So let's actually go see what a deployment looks like. So I've got a few services already deployed. Now, one of the key scenarios where you want to use fiber channel storage is shared storage for a guest cluster. In other words, failover clustering, like maybe with a SQL role, running on multiple VMs in a failover cluster with shared storage. All right. So what I've done here is I've deployed 2 services, one tier which is a SQL tier. Each tier has 2 VMs. So I'm going to show you from the bottom up if I have this virtual machine that's currently off, if I go to the properties, okay. So first thing I want to do is actually onboard the array to the VM. So when I say onboard, I really mean connect. You want to connect the virtual machine and its HBAs to the array. To do that, you need to zone. For those that aren't familiar with zoning, it's essentially you create analogous to a VLAN, you create a connection between ports on the target, which is the array, and ports on the initiator, which is the virtual machine. In this case, I want to have multiple virtual machines in the zone, or at least multiple initiators per zone. What you see here is that we've add fiber channel array to the VM side of the storage, but it's not enabled. One of the reason why it's not enabled, and if you go to the hardware config, is that I'm actually connected to a different vSAN that doesn't have any arrays that can be exposed. Now remember, we're doing end-to-end management. So we're managing the array and we're managing the fiber channel fabrics. So we're doing both. So we can actually tell which arrays are on the necessary fabric. In this case, this particular vSAN is connected to a fiber channel fabric that doesn't have any arrays. So I'll cancel that. I'll flip over to this VM. And if we go to storage, add, now I've got the ability to add a fiber channel array. That means that there's at least one array within that fabric that I can expose to this VM, and it doesn't require zoning at this point. So if I click on this, I'm able to fill in my zone name, what fabric it's going to, what array you're connecting to, the target ports, in other words, the ports on the array that I want to include in the zone, and the initiators for the virtual HBAs that I want to include in the zone as well. So if I go through this and hit OK, one of the things I have to do is actually activate the zone set. So I'm going to skip that step and switch over to a VM that already has the zone created. And the last piece of this demo is then go into Properties, Storage. So I won't add a fiber channel array, but what I'm going to do now is add a disk. So if you're familiar with the Hyper-V host, you can add disks for arrays that are already unmasked or iSCSI arrays that are already exposed to the host. Now we can do this for a virtual machine at the data tier level. Right? So this is basically at the tier level, we're going to expose a LUN to all of the initiators for that data tier. So I'm going to take this LUN that's already pre-created. I'm going to hit OK. Shouldn't take that long. So so right now, what's happening under the covers is that we're actually using SMIS, the SMIS provider implementation for the array to actually unmask or expose the LUN into these virtual machines. So when this task completes, I'm going to flip over to the VM and show you then that the LUN appears, and then you can configure it for any kind of storage that you want, whether it's shared storage for a cluster or just storage for data. It should complete. There we go. I'm going to flip over to VM1, connect. So in here, I've got, now I'm inside the virtual machine. In the disk manager for the virtual machine, I am going simply to rescan for disks. And so what I unmasked was an 11 gig LUN. Simple, nothing big. But the point here is that we've essentially, from VMM console using standard space management, we've gone from an array that has no connectivity to a VM all the way up to exposing the LUN into the virtual machine. And this is what shows up now. Thank you.
Thank you. So just make sure everyone is following along, right? So what we're doing here in this first part of the presentation is telling you the story of how we are continuing to support our array partners and how we're continuing to support fiber channel SANs, iSCSI SANs with the capabilities that are unique to them, like ODX, like the capability to do fiber channel to the guest. Now, I want to switch gears in this talk and talk a little bit about what we are doing in R2 and how we're going to improve our story for what I earlier described as our software-defined storage, right? So what we want to talk about is we are on a mission to reduce the cost, both the cost of acquisition and the cost of operations for storage, because we hear that loud and clear from you that you want more options that will give you SAN-like capabilities with reduced acquisition costs using JBODs, as we talked about. And that story is one that we spent a lot of time thinking during the 2012 release, and we're definitely continuing to work on it in the 2012 R2. How does it look? What is it like? So there are a few key things on this storage vision that we're providing to you. One is the notion that we want to lower cost. The second one is that you are going to have a set of machines that are your compute layer, which are your Hyper-V hosts, and a set of machines that are your storage layer, that is your scale-out file server, where you run storage spaces. And then at the bottom, you have a shared JBOD, which we use as the storage that storage spaces leverages to create these highly available, these resilient storage virtual disks, right? And the notion here is we want the connection between the Hyper-V clusters and the scale-out file server cluster to be a simple Ethernet network, right? So a simple way to deploy your networking between the compute and the storage. And the conversation between the file server cluster and the JBOD is also using a simple SAS connectivity. So this is the vision, and you could essentially say that we deliver that vision in Windows Server 2012 already. Now, what are we doing to make that a more compelling solution? One of the things that we didn't deliver fully in 2012, in VMM 2012 SP1, was the notion of complete management of this entire stack, right? So the idea is, if you want to get to a point where you can use VMM to fully manage that stack that I showed you, VMM has to understand that Spaces is in the picture. VMM has to manage all the capabilities of the scale-out file server. So VMM 2012 SP1 does have the ability to create a share, but it didn't, for instance, have the ability to create a new virtual disk or to create a share from just a pool. So those capabilities are coming in. Also, for instance, categorization of shares wasn't delivered in 2012 SP1, and it's coming in R2. But the notion here, this is a typical slide that Hector uses a lot, which has all the different capabilities, the end-to-end discovery, the pool, volume, and file share classification. You have all these different types of provisioning. Now, one of the things that I like to highlight the most is bare metal provisioning of the scale-out file server. That is entirely new in this release. So what does it mean? So if you've been playing with VMM for some time, you know that VMM has had the ability to provision Hyper-V hosts for a while. So when you need more compute, you go ahead and ask VMM to do the provisioning of those additional physical hosts so that you can deploy more virtual machines. But VMM up to now did not have the notion that you could actually provision the storage layer that we talked about. So on the compute side, VMM was very capable. Now, in that bottom part where you had the scale-out file server, now we have the ability to ask VMM to say, hey, I want to provision a scale-out storage solution for my cloud. And the notion is VMM will be fully capable of doing that from the bare metal. And that is one of the things that we have delivered through the use of what we call the SM API. So what is this SM API that we talk about? The notion is we have a set of capabilities that VMM leverages. So if you see there, one of the consumers of the SM API is VMM. And it lets VMM completely have access to regular arrays through SMIS, but also to have management of storage spaces and to have manage of switches and other components in the stack. So the SM API is essentially a set of APIs that are implemented in Windows, and you can actually go and manage all these different types of devices. So you just saw, which I think is something very impressive, the ability that VMM has to actually go and deploy virtual fiber channel to do zoning and unmasking of these fiber channel solutions. Now, we're taking that further and enabling the management of storage spaces as well in a similar fashion, so that VMM can come in and do the spaces management in addition to the traditional array management. So what are the main things that VMM delivered in this release? So coming over there, you will see that now we have full volume classification. We have full echo management in VMM. We have also the ability to have your VMs deployed to file shares. So in essence, some of those capabilities you already had in 2012 SP1, but especially the first part, the pool volume provisioning, is new in R2. Then in the middle there, you see the bare metal provisioning of the file server that I was talking about, the actual creation of the cluster. So create the machines, then make those machines into a cluster and add nodes to a cluster, remove nodes to the cluster, all done through VMM. Right? And obviously file share management, creating shares, echoing shares, all that. And at the bottom with the spaces integration, discovery of the disks that you have behind the physical spindles, creation of pools, creations of spaces, which are the virtual disks. So a complete solution so that in that stack that we described here, you can actually go ahead and start using VMM as your single tool to manage the entire stack. One of the things that we also delivered in this release, which I think is very interesting, so we had a solution for doing iSCSI to the guest for guest clustering. Hector just described how you could use virtual fiber channel to the guest and have a guest cluster that way. We are introducing in 2012 R2 a different way to create storage for your guests and to create those clusters in a simpler fashion. Because honestly, today what you have to do to get that storage to the guest is you have to wire the storage, the iSCSI storage or the fiber channel storage, all the way to your VMs. And sometimes that's not a simple thing to do, sometimes it's not a convenient thing to do, and it makes your solution for iSCSI look very different from your solution for fiber channel. And in this case, what we wanted to also make sure that we can do is we can use spaces storage or file share storage and use that for guest clustering as well. So we thought about it a little bit and we came up with an interesting solution. Essentially, you can just share an actual VHDX file. So if you want to create a cluster in the guest, you basically have the disk that the guests boot from, but you can actually now get a single VHD and expose that to 2 VMs as a data disk. And what the VMs will see, they will see a disk that is clusterable. So all you have to do is create your boot disk, one for each VM, and then create your shared VHDX files, which you expose to those, and you create a cluster that way. So you don't need to wire virtual worldwide names all the way down to the guest. You don't need to actually use the initiator and the guest. You just do this through the sharing of VHDX files in the host. That's a new capability. And I'm very glad to say that not only we delivered this new capability in Windows Server 2012 R2, but also VMM is fully capable of managing that new capability in VMM 2012 R2. So we're simultaneously supporting this both in the OS and in the management layer. So we hope that this will bring a lot of simplification to the scenario of guest clustering. Another thing that relates to our storage solution that we ship in box in Windows, we have our iSCSI target that we also provide as part of Windows Server. It's one of the roles. And that management of the iSCSI target was something that VMM delivered in the previous release, but now, for the first time, we're actually shipping that SMIS provider in Windows itself. So when you load the iSCSI target in Windows now, not only you load the actual iSCSI target role, but you also load the management for that iSCSI target so that VMM can simply come in and manage the target. Right? In 2012, in VMM 2012 SP1, what you basically had to do, you actually had to go and load that management component onto your hosts. They did not come with the host. Now it's built in. Now, another thing that we did to improve the iSCSI target was the notion that before we were using our iSCSI target with VHD files, the old VHD format. And that came with some limitations. So by now you probably know of all the new benefits that we have in the VHDX format, the larger size, and all these new abilities that we have in the VHDX format, the alignment and all that. So we brought that to the iSCSI target. So now the iSCSI target will use VHDX files with up to 64 terabytes in size. And also you have the ability now to use dynamically expanding. The target before was all fixed disk. So again, improvements delivered to the target with matching capabilities on VMM to manage the iSCSI target that we provide in box. And with that, I want to call Hector back to share with us some of these new capabilities to manage our software-defined storage stack.
Okay, thank you, Jose.
All right.
So I'm going to switch now to the Fabric view in VMM, and so the Fabric view essentially gives you storage, compute, and networking, all the devices that we manage. In particular, in the storage piece of this, we've got several nodes, classification and pools, the providers that we use to connect to all these devices, the different arrays that we manage, the file servers that we manage, and also the fiber channel fabrics. So if I click on file servers, the first thing I want to show is that we obviously have management for a file server. That continues to be the case from SP1. Now, the pieces that we've added is now the bare metal provisioning of a scale-out file server. So there's a lot of components involved in bare metal provisioning, so I'm not going to go into each one of them. I just want to get it from a show of hands. How many of you actually have used VMM bare metal provisioning for Hyper-V? Okay, so really quick, just to set the context of what's going to happen here. Bare metal provisioning essentially assumes that there's no operating system on the physical machine. What we do assume is that there's a baseboard management controller, or a BMC, a Dell DRAC or HP ILO, etc. Now, those devices allow us to power on, power off machines with no operating system. So that's the first thing we communicate with. We essentially get an IP address, a set of credentials, and we access the BMC. We tell the BMC, power on the machine. Now, when it powers on, we assume that it's going to PXE. So in the BIOS, you can set the boot order. If it PXEs first, in other words, and it's going to PXE anyway if it has no OS, but the idea is that if it PXEs first, WDS is going to pick that up. Windows Deployment Services will get that PXE request, and then we're going to start downloading WinPE. WinPE is essentially that pre-installation environment where we're going to configure the disk and lay down the first boot VHD. We're going to configure that to be boot from VHD. So we don't actually do imaging to the disk. We just download the VHD, change the boot config, and then we just boot directly from the VHD. So now, and we do that several times. So we do that for any number of servers that you add into the profile. I'm not going to answer that right now. So let's say I have a 4-node cluster. We're going to bare metal provision each one of them. We'll stand up 4 instances of Windows. Then as part of all of that, we're going to enable the cluster role. We're going to add the scale-out file server role that needs to be added in the failover cluster. So we're going to do all of that work as part of the automation. All right, so let me show you that first piece. So if I switch to the library, in the library, we've got what are called profiles. And you have hardware profiles for VMs, for VM templates. You've got guest OS profiles. And one of the renamed profiles is physical computer profile. This used to be VM host profile. We've essentially up-leveled it, made it generic, and so now you essentially create a profile for a physical computer, and then you pick the roles that you want inside of that, the machine that's going to be deployed. So if I go to create physical computer profile, so the first thing I'll do is give this a name. So this name of the template, the profile, and the role that I want installed. So today we are limiting this to Hyper-V or scale-out file server. So you essentially pick the role that you want, hit next. Next thing I'm going to do is I'll tell the profile I want a particular VHD. So we're pulling VHDs from the library. The VMM library is essentially a collection of ISOs, VHDs, script files, etc. So I'm going to pick the VHD that I want to use for boot from VHD. And then I go in and start configuring some of the hardware. One of the first things I might want to do is set a static IP. I can set static IP per NIC, per NIC, or I can set it for DHCP. And then the other important piece is I want to set up the OS disk. So the physical disk is going to get provisioned where the VHD will land. I can make it a particular size if I want, or I can just consume the entire disk. The other important part of this profile is what domain am I going to join, what credentials I'll use to join the domain, what admin password, product key, etc. So all of this is put in and staged into the template. And so the end result is a profile. I haven't deployed anything yet. So I'm going to use this profile to stamp out new physical machines that will eventually make it into a scale-out cluster. So how do I do that? I go back to Fabric, and then I'll do create. Sorry, create. And then you'll see here that we have Hyper-V cluster. Again, this is using bare metal. This is going to bare metal provision a set of hosts, make them Hyper-V into an Hyper-V cluster. And the new one here is file server cluster. Now, first, few questions I'm going to answer. This is my demo cluster. This is my scale-out file server. So two things. I need to name the cluster. That's the cluster endpoint on the network. And I need to name the file server itself. So those two names are as inputs. There's two options for provisioning scale-out file server. Either you have servers with an operating system, which you can add into this wizard and say, use these machines that I've already provisioned. They've already got OS, IP address, everything's ready to go. Go and enable clustering, enable the roles, and make it a scale-out file server. Just make it happen. The more interesting one is if I flip over to bare metal provisioning. This is where I get to pick my profile. So I pick the profile from the one I just created. Now we go through the process of telling VMM what's the credential that it should use to access the BMCs, the baseboard management controllers. So let's assume I've got an account. We use two standards, IPMI and Smash, to communicate with these baseboard management controllers. So that's all built in. And then we're going to give VMM the IP address to go look for those BMCs. So the end result of this wizard is that once we identify all the BMCs, we're going to start powering on all the VMs, all the physical machines. We're going to start the boot process to get them configured with an OS. And the end result of this scenario is that you will have a scale-out file server fully configured. Okay? So that's the first step. So we're essentially automating and turning this into more of a turnkey solution, so you don't have to know all of the bits and pieces of how to actually create this. There's a lot of manual steps that go into creating a cluster. Pretty sure you're all aware of that. We want to simplify that. We want to make it consistent. We want to make it so that you can deploy these from bare metal in a consistent fashion using a centralized management tool, leveraging all of the capabilities of the platform, and you get a consistent experience every time you do this. Now, once I have a scale-out file server, I can go in and do some management operations. One of the interesting ones is if I want to manage pools. Now we're talking about spaces pools. In other words, pools created from physical disks that are attached via SAS to these nodes. And I'm going to use those disks to create a spaces pool. And from there, I will carve out spaces or virtual disks. So in this case, I've got two pools. So obviously this is a demo environment, so it doesn't have a lot of disks. But I could go in and, let's say, create more pools. But I've already done that piece. I've already done all the discovery for the physical disks. I've already added them to a pool. And I've already gone as far as classifying them. So in this case, this is my fast pool. And it's right now, and it can be using SAS or SSD. Okay. The final step is now to actually do the file share creation. So if I go to create in a ribbon, and I create a file share, essentially through this dialog, we're actually going to do several pieces. We're not only going to create the file share, we'll actually do all of the storage provisioning on the spaces side. So what are some of the questions that I have to answer? First, I need to have a name. I'm going to pick the pool that I'm actually provisioning from. So I pick the type of storage, I pick the pool by name. I can either leave the classification alone or set a different classification, and then give this a size. And then you set your file system. So when I hit create on this, in this dialog, VMM is going to go off into the background, and the process that it's going to follow is it's going to look for the pool, carve out a space. So in this case, it could be a 10 gig space, it could be a 100 gig space, whatever the size that you specified. That space will get attached to the cluster. It'll become a clustered space. Once it's attached, we'll initialize the disk, partition, format. Once it's formatted and has a file system, that's when we can layer on the folder structure and then layer on a file share. So what that one wizard did is actually automated that entire workflow. Again, consistency, rapid creation, really the turnkey solution experience for creation of file shares. Then the last piece I would have to do is so now that I've got VM Store 03, if I want to actually deploy virtual machines, I right-click on the VMM demo clue, which is a cluster, Hyper-V cluster. I go to Properties, and if I click on File Share Storage, right now I don't have any shares exposed, but if I click Add, one of the shares that I can now expose is the VM Store 03. Now, when I say expose, I don't mean unmask, I don't mean any of the block semantics. We're basically talking about ACLing. So we go off and ACL the share with every computer account for every node in the cluster. So if it's a 64-node Hyper-V cluster, we'll go off and do all of that work. So when I hit OK in this wizard and complete this workflow, you will actually now be able to deploy virtual machines to that file share. Thank you.
Thank you, Hector. You know, this is truly impressive stuff, because if you think about all the work that goes into doing this manually, right? We have PowerShell for doing everything that we describe here. We can create pools, we can create file servers, we can, add the new space and put it on a cluster and then create the share and do the ACLing, do all these things through PowerShell. And I'm a big fan of doing that through PowerShell. But when you look at how VMM delivers on this solution, and you can actually just manage it all centrally, you can imagine how we can actually do this at scale, right? Because that's the main thing. You can do it manually for a small environment, but as you get bigger, as you have tens of compute nodes and you have hundreds of disks, you don't want to be doing this manually anymore. You want that automation to be there in place. Now, let me talk a little bit about what we changed in the file server itself. So on the scale-out file server, we have a few new things that we put in R2, again, in the spirit of improving that scenario, rounding up the capabilities that we have. So if you're interested in a big overview of what the scale-out file server can do and all the capabilities of SMB, I have a talk coming up tomorrow where I'm going to spend the full talk on all things for the file server, covering the 2012 capabilities and the 2012 R2. But in this talk, I want to highlight just a few. One of them is our performance with RDMA. So you probably heard about our high-speed, low CPU utilization solution that we deliver in 2012. Now, that worked really well for large I/O. And if you had a 10 gig NIC, even for small I/O. Now, what we're doing here, we're trying to make sure that this is something you can invest in. It's future-proof. So we are now delivering in this R2 release an improvement from about 300,000 I/Os per second, which is what we could do in 2012, up to 450,000 I/Os per second on the same hardware that we did before, right? Obviously, with this many I/Os per second, that's per interface, by the way. So with this many I/Os per second, we're talking higher speed NICs. So this is only going to be relevant to you if you're deploying 40 gig NICs or 56 gig NICs. If you're doing 10 gig, you actually won't get better IOPS because we're already doing great IOPS there. Now, even from 10 gig, we will further reduce our CPU utilization. So these are improvements across the stack to deliver this. So this is improving on top of what we did in 2012. Now, the way to deploy these things, same as 2012. The overall configuration, exactly the same. It will just perform better with our new code. Another thing that we're doing, in 2012, we delivered a scale-out file server, and that scale-out file server had the ability to spread load across the multiple nodes. However, every client will talk to only one of the nodes in the cluster. So for instance, if you had a 2-node file server cluster and you had 10 Hyper-V hosts, 5 Hyper-V hosts will talk to one node, 5 Hyper-V hosts will talk to the other node. But you would never had one Hyper-V host that would talk to more than one at a time. So we are now introducing the notion of doing per-share scale-out, which is new in this release. We're also now aware of something that is in the file server side, which is the ownership of the volumes. So when you're deploying a mirrored space, there is one of the nodes that has better access to that storage. So ideally, you would actually direct clients going to that space to that node, which is the best node for access. Now, what we did in this release, we did a combination of things. First of all, cluster itself is now going to naturally spread the volumes across the nodes. So if you have 3 nodes in your file server cluster and you have 6 CSVs, 6 cluster shared volumes, you will naturally end up with 2 per node. So that happens automatically. On top of that, when you connect to the shares, they will know which one is sitting on which node, and the clients will be directed to the ideal node for that connection. So this is essentially scale out that scales better and scales automatically without any need for you to do any balancing. It just happens automatically. Again, if you're deploying Windows Server 2012, you actually deploy it in the very same fashion, same procedure. The only difference is now the scale-out file server will know how to balance better, and it will happen for you. Okay? Another thing, not sure if you watched the keynote, but on the keynote, people were starting looking at RDMA in the 2012 release, and one of the folks that looked at that was the Hyper-V team itself. And they came to us saying, you know what, I love that ability to perform high-speed transfer with very low CPU utilization. Can we use that for migration in Hyper-V? And then we coordinated with the Hyper-V team, and now the Hyper-V team has as one of the options, the option to use SMB in our high-speed networking capabilities to perform the memory-to-memory move of the VMs. So the live migration now can leverage SMB as a protocol because of the efficiencies we put in place. And by the way, we also have multi-channel. So if you have multiple NICs, we actually aggregate that capability. So if you have 2 10 gig NICs, you can actually live migrate at 20 gigs of throughput with this new capability. So very interesting. And on my section, I actually have a demo of this that's quite interesting as well. Now, one of the things that people will start looking at is SMB is now being used for VHD file access, for migration, for the cluster backend communication. So there are a lot of different things flowing over SMB. We now have also a feature that allows you to shape the traffic of that SMB communication. So you can say, okay, I want live migration over SMB to use only up to this much bandwidth. And then I want my traffic to the actual VHDs that are running my VMs to have this much. So we introduce also the notion of having further control of bandwidth there. Now, if you combine this with Hyper-V's ability to do per VHD storage quads, you can actually have a pretty interesting solution to control the shape of your I/O. Speaking of that, a few things that happened on the Hyper-V itself. We heard loud and clear that the notion of having to take downtime to resize a VHD wasn't a good idea. So Hyper-V is delivering now online resize of your VHD files. In addition to that, as I mentioned, we now have storage costs. So for instance, if you're deploying 10 VMs, you can actually say for each of those VMs, so the VHDs that they use, this, for instance, if it's a hosting environment, you want everyone to get up to, I don't know, 300 IOPS. So it will enforce those so that one VM cannot be a bad neighbor to the other VMs and start using all your storage resources. So this is also new in this release, and also some additional metrics that you can look from VM, for instance, related to how many IOPS these VMs are using. So you can now set a maximum that will be enforced, and you can also monitor and have alerts for minimum IOPS. So let me show you a few things here. All right. So I have in my environment here a cluster that has a few nodes. And if you look at what it has right now, you'll see that I have my 2 nodes. So node 1, node 2. And this is a scale-out file server, as you can see here. Okay? Now, I want you to pay close attention to one thing here. So in this scale-out file server cluster, I have 6 different cluster shared volumes plus a witness disk. Okay? In this environment, you will see that A1 has about half and A2 has the other half. Now, first thing, I did not make that happen. It just happened naturally. As you create CSVs or you add nodes to the cluster, it automatically spreads them out across the cluster, right? So that is one important thing. Now, another thing that I'm going to do here now is I'm going to start a workload. So this is a single machine that is hitting all 6 shares at the same time. Now, notice what's happening there. Both nodes are being accessed. So single client hitting 2 nodes of the scale out because we're doing per share. So the shares that are on the volumes that are on A1 are being flown to A1. The shares that are on the volumes going to A2 are going to A2. So that's a new level of scale out in this release. We would not be able to do this in 2012. In 2012, what we would do, we would pick one of the 2 and talk just to that one, and we'll let the traffic redirect on the server side, right? So this is an improvement. Now, on this demo, I wanted to show you that I have the ability to add a node to this cluster. Now, in the past, if I were to demo this, I would be demoing it through Failover Cluster Manager. But now that we have full management capabilities in VMM, what I'm going to do is I'm going to go over here to VMM. I'm on my fabric. I'm going to go ahead and say right-click on my cluster here. And you can see that this cluster currently has 2 nodes. So what I want to do is I want to add a node to this file server cluster. And I'm going to go ahead and say OK. So when I say OK there, what VMM is going to do is going to start a job. There it goes. And VMM is going to do everything that is required to add a node to this cluster. It is going to add the failover cluster role. It's going to add the failover clustering feature, add the file server role. It will add the node to the cluster, and will fully make sure that all those steps are followed. And I don't have to worry about how that's going to happen. Now, that's going to take a while, and I'll let it run there. And I'm going to use the opportunity to show you another demo. So that was a scale-out demo where I had multiple nodes. The other demo that I wanted to show you is a little performance demo, right? So over here, I am connected to another system. That's actually a remote system with an interesting set of hardware. So I have 48 SSDs on the file server side, all in a single space, in a single mirrored space. And I have very good connectivity to those 48 disks. I'm going to go ahead and get a workload started here. And I have some performance counters on this side over here. Let me explain what's going on here. So I have, on one side, I have a host that's over the network talking to a file server that's talking to 48 SSDs. And what I'm delivering there is nearly 600,000 IOs per second, right? Those are not really tiny IOs. They are 8K IOs. Those are the ones that I have talked to you about. We are optimizing for those. So nearly 600,000 IOs per second over the network to the other side, okay? This is exercising our full stack, meaning that we have a file server client talking to a file server, talking to storage spaces, talking to SAS, to our storage, okay? So this is to prove our improvements in our performance. I'm going to go ahead and switch to a different workload. So I'm going to wind that down. I have, essentially the way I did that, I have 16 different SQL I/O simulations. Each one is doing a little bit of work, and together they get to that point. I'm winding that down, and now I'm running another workload. Now, on the previous one, I was actually limited by the storage that was on the other side. So I'm now doing a cached workload. So how's the cache workload happens? I have those processes running on one side, flowing over the network to the other side, but instead of going to disk, I'm going to memory directly. And this is just to show you the amount of work that we did in our networking stack. So in this case, I'm exercising only my networking stack. So I'm right now at about 800, high 800s, and I was really hoping that we would go a little higher. Come on. You can do it. Oh, I'm sorry. Today it's not doing what I wanted it to do. I actually have a recording of this guy going all the way up to 1 million IOs per second over the network, right? So the whole notion here is in terms of workloads, when you go up to 500, 600, 800, 1 million IOs per second, we're basically in high-end SAN territory. So what I'm trying to prove here is that we can actually perform really well. And the last one that I wanted to show is when you're trying to move lots of data and we have larger I/O, we could always deliver very good performance. Now, in this specific configuration, I have 3 NICs. Each NIC can deliver 56 gigabits per second, right? And when we are doing these workloads over these 3 NICs at the same time, I have a feature called multi-channel that allows me to aggregate. So effectively, I can go all the way up to 150 gigabits per second. So I'm winding down that workload. I'm going to bring the other workload up. So what I'm trying to do is see how much I can put on that wire and make sure that I can get great throughput as well. So now, the way I'm doing this is instead of using 8K IOs, I increase my IO size to about 32K. And what you see here is I'm doing 500,000 IOs per second. But what I really wanted to pay attention is the throughput number. So that is the number of bytes that were flowing per second on that network. This is going to disk all the way, right, to a mirrored space. And we're doing 16.4, 16 and a half gigabytes a second. For perspective, this is the equivalent of 15 10 gigabit Ethernet NICs. This is a little more than 28 gig fiber channel HBA's worth of performance, right? So what I'm trying to show here is the notion that when you are doing this kind of work, you essentially will have a solution that will scale really well on the full stack that we are talking about, okay? I want to actually kind of move forward here quickly and talk about a few other things. So one thing that we heard from you is data deduplication is a great capability in our platform, and we deliver that capability in Windows Server 2012, okay? Now, that came with a restriction. You could only use data deduplication for certain types of workloads. So more specifically, you couldn't use it for live VHDs. We said, okay, you can dedupe your library, you can dedupe your traditional files, but you should not dedupe in Windows Server 2012 your live VHD files. But we heard from you that that was an important thing to do. So in this release, we are going to introduce the notion in R2 that you can actually, in the VDI scenario, dedupe live open VHD files. That work specifically to support the VDI scenario includes a series of new capabilities, including support for CSV and support for faster speed so we can keep up with a workload running. Have you seen the demo on the keynote? That actually ended up delivering improved performance with deduplication, which is a little bit counterintuitive, but because dedupe has some caching mechanisms, when you are in a VDI environment, you actually get better performance, okay? And with that, I'm going to transition over into our storage spaces solution. So one of the things that we have talked about plenty is the capabilities that Spaces introduced in Windows Server 2012. So get a set of disks wired directly, create a set out of it. However, there were still things that we could improve. One of these improvements is the rebuild times, right? So when you have a failure in one of the disks, what Spaces needs to do is it needs to use the remaining disk to spread that redundancy around. So for instance, if you have in that case, 8 or 10 disks and one disk fails, you have to immediately get all the data that was redundant there and start spreading it across the surviving disks. And then you obviously want to remove that disk and put a new disk in. So there was a lot of work being put into doing this in parallel so you can recover and rebuild much faster. So you have some statistics here about the time it takes to rebuild, for instance, some 2.4 terabytes of data. So that is a very important metric because it will give you the notion that if there's a disk failure, you will be able to quickly recover and be again protected. Because when you have one failure, you don't want to have another failure. The other thing is also that Spaces is now doing triple mirroring as well. So if you are doing Spaces, you can actually have 2 copies or 3 copies as well. Now, to be honest, the one feature that people are talking about a lot is tiering. Tiering is finally giving you the freedom to not have to choose between SSDs, which are extremely fast, and ideally we'll put everything on SSDs, but SSDs also have some limitations. Typically, SSD drives are smaller, and they are much more expensive. So you want to have your hard disk drives for capacity, but you want to have your SSDs for performance. So in this release, we are introducing the notion that you can actually create a single pool that has both SSDs and HDDs, and Spaces will now automatically track which data is being used more frequently, and will move the hot data to the SSD tier, and will keep the cold data in the HDD tier. This is a feature that has been delivered before in storage arrays at a premium. Right now, this is a native capability of Windows Server 2012 R2. Okay? Oh, and I'm going to call Brian to come over to do a demo. And I forgot to show you that my cluster got the third node added, and it's now rebalanced. So remember, I added a node to the cluster. This is what happens in the end. Not only the node was added to the cluster, but the CSVs got spread across the nodes, and now my single client is talking to all 3 nodes in the cluster. Okay? All right, which one is you?
6, right?
All right. Brian.
Thanks, Jose.
Thank you.
Good afternoon, everyone. I'm Brian Matthew, Program Manager in Storage and File Systems team. Our team basically delivers the storage platform across Windows, scaling from delivering storage in Windows RT devices all the way up to delivering storage in large data centers. So our team has to consider scale at each level. Jose talked about tiered storage, and we also have a capability, write-back cache, which I'll also talk about. Write-back cache is a new capability in R2, which is a per virtual disk persistent write cache that utilizes SSDs in the storage pool to smooth out periods of random write activity, such that these random writes, they don't negatively affect the ongoing workloads. So I'm going to show you a demo on the write-back cache first, and then I'm going to show you a demo on storage tiering. So here I have 2 perfmon windows. They're showing perf counters for 2 different virtual disks. One virtual disk with a write-back cache, the other virtual disk is without a write-back cache. I have workloads running on both virtual disks, identical workloads, and it's delivering about 550 IOs per second, as indicated by the blue line. Superimposed to the blue line is actually a red dotted line, which indicates the overall IOs per second being done on that volume, which means from my blue line workload and any other workload I introduce, which is going to be the write spikes. So now on each volume, I'm going to throw some write spikes at it and see how each volume handles it. So here's a write spike. You can see that the dotted red line, which indicated the overall IOs per second on the volume, increased, meaning more work was done. Blue line workload had work, and the other write spike had work. However, the volume without the write-back cache, you can see that because of this write spike was introduced, the blue line workload was negatively affected. It went down. However, the volume with the write-back cache, everything was smooth. So let's throw another write spike at it. And again, write-back cache absorbed this short-term burst of write activity. My blue line workload was not affected by this write spike. And this is exactly what we design write-back cache for. And in your data centers, you're going to have a lot of random I/O. You're going to have writes come in. You don't want your workload as impacted by these writes. Let's continue to a tiering demo. What I'm going to show you is the seamless transition of a file that is currently completely located on the HDD tier to the SSD tier of a virtual disk. Now, the kicker here is that during the data movement, this file is going to have an intensive I/O test occurring to it. So I have another perfmon window. And as I said, this file is completely on the HDD tier. I have an intensive I/O workload occurring to this file, and it's delivering me approximately 2650 IOs per second, which is about what you'd expect from the disks I'm using. So I'm going to kick this file over to the SSD tier, and I'm going to immediately trigger data movement. Now, data movement would typically happen every day at 1 a.m. It's a scheduled task. You can configure it. But in this case, I want it to happen immediately for the sake of the demo, unless you folks do want to stay to 1 a.m. So you can see that data is being moved in the background. The blocks that were previously on HDD are now being moved to the SSD tier. This occurs all transparently underneath your workload, transparently underneath your data access. As more and more blocks are being moved to the SSD tier, the random IOs per second to this file go up. Now you can see that it's plateaued at about 60,000 IOs per second, indicating this file is now completely located on the SSD tier. It was doing 2,600 before. It's now doing 60,000. This entire transition was seamless while an intensive IO workload occurred. And you can see there was no noticeable drop in the performance of the IO test during the data movement. So the data movement was quick, it occurred transparently, and it didn't impact the workload. Now, typically, Windows would do this movement automatically, depending on how frequently accessed your file is. If your file is hot, we'll kick it to the SSD tier during the periodic processing. If the file is cold, we'll kick that file out of the SSD tier and move it to the HDD tier. This is all automatic and configurable. Or, of course, administrators can override this automatic placement, as I've done in this case for the sake of this demo. I have a session tomorrow at 5 p.m. It's MDC 217 that walks through spaces and the file server cluster stack. And I go through a little more details of tiering and write-back cache and our new R2 capabilities. So do be sure to attend that talk. Thank you. I'll hand it back over to Jose.
All right. All right, so we were set out here to do something really hard, which is to show you all the different improvements in all these different areas in about an hour, right? And I think the message that I want you to get from this, aside from the fact that we're delivering a whole lot of value in a short one-year release, is that we have a consistent trajectory that we're traveling along, right? So we have this vision for storage where you have spaces, you have the file server on top, and you have management through VMM. We also have very consistent support from Hyper-V going into the file storage, going into spaces. And we have been working to make that story complete. Now, we don't want to jar you. We know that you're currently planning your deployments. You might be already deployed in 2012. So the story is very consistent. The things you did before, they rhyme with what's happening now. We're just doing it more automated, faster, and delivering some of these scenarios that are key, right? What I want you to take away from this is we're doing work in all the areas that matter in performance and scalability and reliability and reducing costs and management as well. And the notion is, as we move forward, we will continue to invest in this vision of software-defined storage, where you get a lot of value from your Windows Server deployment, okay? As Brian mentioned and Hector mentioned as well, you should consider this session as an introduction that will have deep dives. So we have additional session on deduplication, where we're going to have some demos and details on how deduplication works in that VDI scenario that I mentioned. We're going to have details from Hector on VMM. We're going to have details from Brian on source spaces, a couple of sessions. And I also have a session about the Hyper-V over SMB scenario, where we're going to spend some more time, maybe even do a demo of live migration over SMB as well. And I invite you to go ahead and take a look at those sessions which are coming, okay? We also have a lot of resources coming out. So you probably heard that the build is now available for download, so you can go get your preview bits and start playing with it. We also have some new content available on TechNet that helps with your deployment there. So for instance, the shared VHDX scenario, we have a step-by-step published already. We have an overview of what's new in Hyper-V, always being deployed to TechNet, and we urge you to go there and experiment with it. There's very interesting things going on specifically this week, right? And of course, we want you to fill in your evaluation for our session. And we want to thank you for coming over and taking a look at these new things. And we welcome your questions now in public if you want. I think we're about out of time, I want to say. But feel free to come over to the booth or to come over here, and we're glad to answer further questions. Okay? Thank you.